Hello everybody and welcome to MrMiers Math Channel. Today in Algebra 2 we're talking about parabolas, which is section 13.2. Our goal is going to be to graph parabolas in vertex form. Some applications of the parabola. Of course in math we always have some applications in terms of some real life context. So we have the Golden Gate Bridge on the left. The Golden Gate Bridge forms a parabola. We have the main cable here, and then obviously the suspenders which form that parabolic shape. And then also, of course, the satellite dish is parabolic in nature, and that helps it transmit and receive messages. So getting into talking about the graph of a parabola, we have vertex form. Now we did already talk about vertex form in this last section. So we graph functions in vertex form. But this isn't the only vertex form for a parabola. Right? This equation is in terms of y, and we can also have equations that are in terms of x. So for this, in terms of y, just as a brief review, the vertex is the point h, comma k, and one point to make would be h is what we're subtracting from x. So if that's x plus something, then that's a negative. If it's x minus something, it's a positive. And then k is whatever we're adding or subtracting at the end outside those parentheses there. The axis of symmetry occurs right at that x value. All right, so that would be x equals h. So really all you have to do to find the axis of symmetry is set what's inside the parentheses equal to 0 and solve. And then finally, for the direction of opening, that's dependent upon a. Now if a is greater than 0, it opens up. And then if a is less than 0, it opens down. Okay, so this is for our parabolas that we went over in the previous section, but we also have different types of parabolas like I talked about. We could have a parabola that says x equals instead of y equals. So let's get into that next portion to talk about the features of that type of graph. So for that type of graph where we have x equals, the vertex, axis of symmetry, and direction of opening is going to be a little bit different. Okay, the input value here is the y value, all right, and the output value is the x value. Okay, so since the input value is the y value, we're going to see a different shape, or I guess a different orientation of this parabola. So the vertex for this parabola is going to be the point h, comma k still. But notice the location is different, right? H is on the outside, so H is actually unaffected right here. So H is going to be whatever we're adding or subtracting, all right? And then K is going to be whatever we're subtracting from Y. So that's a little bit different. And then also our axis of symmetry, we can find it in the same exact way. Just set what's inside the parentheses equal to 0 and solve. And if we do that, we just get Y equals K. So our axis of symmetry is going to be a horizontal line. All right, so the shape of this function is either going to be something like this or something like this. All right, I know that's a horrible sketch, but just wanted to do it rather quickly. So that means the direction of opening is either to the left or to the right. Now, if a is positive or greater than 0, that's going to open to the right. All right, and that kind of makes sense because it's opening to the positive side of the graph. All right, if a is negative or less than 0, it's going to open to the left. Also kind of makes sense. It makes sense if you're thinking about this in terms of the x-axis. All right, so now let's get into the first example. So we're going to graph 5 different functions here, and then some of them are going to be in terms of x, and some of them are going to be in terms of y. All right, so in example 1, we have an equation written as x equals 2 times the quantity y minus 2 squared minus 5. So we're going to find the direction of opening, vertex, and axis of symmetry using the notes that we had on the previous slide. So first we'll start with the direction of opening. All right, that's dependent upon a, and in this case a is 2, so that means a is greater than 0. Since a is greater than 0, it's going to open to the right. All right, for the vertex, Remember, the vertex is that point h comma k, but h and k are located in different spots here. All right, h is going to be -5, and then k is going to be +2. That's what we're subtracting from y. And then for our axis of symmetry, it's going to be a line that says y equals, it's going to be a horizontal line, at, of course, then 2, okay, because that's the y value of the vertex. All right, so some things are different than a normal parabola that we graphed in the last section. All right, so we have y equals 2 as the axis of symmetry. You can make that dotted line. Now let's draw the vertex. -5, 2. Now it's opening to the right. And then using some things that we know from our previous lesson, a is 2. So the first increase is going to be by 2. And we're opening to the right. So when we're talking about that increase, we're talking about an increase in terms of x. So we're going to go up by 2. And just to write down the increases for a parabola or for a quadratic function, the change over time here is +1, +3, +5, +7. Since a is 2, we're just going to multiply 2 by each one of these. So it's going to start with +2, +6, +10, +14. Not that we need to continue all the way up to 14. So we did our +2, now our +6. That's right there on both sides, and then obviously we're not going to be able to reach +10. All right, so that's good enough to make our parabola. I'll do the best that I can in terms of the graph. I'm not very good at graphing functions typically, but I try. All right, let's move on to example 2. All right, I'll go through these rather quickly. These are the same types of parabolas that we went over in the last section. Okay, so we're going to go pretty quickly through this. The direction of opening is going to be down, and that's because a is negative. Okay, the vertex is going to be the point -1, 3, because we have -h, x minus h here, and then k right here. And then the axis of symmetry is going to be x equals -1, so that's a vertical line, which we're going to draw right here. And then the vertex is the point -1, 3. That's right here. Now on this one, we might want to use our graphing calculator to form a table. Otherwise, if we're forming a table by hand, we have our x and y values. Okay, that vertex goes right in the middle. Okay, then we can just go down by a few, up by a few, and check it out and see if that works. All right, so I'm going to fill this in with what I have. Obviously, for these functions, we can just straightforward type them into the calculator, but if a function was in the form x equals, it's not immediately clear how we would type it into the calculator. And maybe I'll talk a little bit about that in this next example here. All right, for this example, we get 0 for -4, about 1.67, 2.67. Obviously the same on this side, and that's at least enough to get us started. Usually I like to run through the entire graph. -2, 2.67. -1, 3, 0, 2.67. 1, 1.67, or 1 2/3, in other words. -3, 1 2/3, and then we get to 4 there. Okay, that might be enough. If we want to just get another point, 5, -9 is another point on this graph. Okay, and it would be the same on the other side. All right, and now we can form our parabola. There we go. All right, let's move on to example 3. All right, in example 3, we're going to graph the equation x equals negative 1/2 times the quantity x plus 5 squared minus 6. So let's find the direction of opening. In this case, since a is negative, this is going to open to the left. And then in terms of the vertex, make sure that we remember here's our h, that's just negative 6. Here's our k, which is negative 5. And then that means the axis of symmetry is the y value, not the x value, right? Because this one's opening to the left, or horizontally rather. So y equals negative 5 is shown here. All right, remember that's not actually part of the graph, but that helps us give us a guideline as to how to graph this function. Now we have negative 6, negative 5. All right, negative 6, negative 5 is right here, and it's opening to the left, so this is going to be rather quick to graph. All right, notice that change is 1/2, so really we're just going to go 1/2 on these next two y values. And then obviously it increases, a equals 1, and here's our increases. If a equals negative 1/2, we just multiply by each one of these. So the next increase, or decrease I should say, would be negative 3/2, negative 1.5, right here. And then by the time we get to the next one, we're already off the graph. There we go. All right, folks, that might be enough for most of you. Otherwise, I'm going to continue and go through those last two examples. If that's good enough for you guys and you enjoyed it, make sure to like, subscribe, and share. On to the next two examples. In example 4, we have y equals the quantity x plus 1 squared plus 1. Now in this one's rather simple. We have an implied a value. A is right there, and what we're multiplying here is just 1. So a equals 1, which means the direction of opening is up since that's positive. All right, and then for our vertex, we have our x value, what we're subtracting by x, negative 1. And then our y value, what we're just adding to the overall function, that's positive 1. And then our axis of symmetry is just going to be the value x equals negative 1. I'm going to graph that right here. All right, and then negative 1, positive 1 is right here on the graph. Since a equals 1, it's going to be really easy to find these other values on our graph. Okay. Hopefully, if we see this pattern, we can just continue to use this pattern. Otherwise, obviously, if a is some decimal value, it might be a little bit more difficult to do. But if a is some whole number value, it's actually pretty easy to not build a table and to not do all this work in finding the other points on the graph. So first, the increase is going to be by 1, then it's going to be by 3, then it's going to be by 5. Boom, we're done. Awesome sauce. Cool beans. All right, in the last example, we have y equals negative 2 times x squared minus 1. So in this one, obviously this is not in vertex form. It's in standard form, but it's a rather simple one that's in standard form. So we can still do these features of the graph. The direction of opening, obviously, is still dependent upon a. Whoops. But a is still right here. We still have ax squared. Remember, in standard form, it's ax squared plus bx plus c. And fortunately for us, we can find a and c right away. So the direction of opening is going to be down. Okay, the vertex is going to be affected by that minus 1 at the end. All right, but x is going to be 0, so the vertex is going to be 0, negative 1. And then the axis of symmetry is x equals 0. So let me graph that axis of symmetry. And then from there, we're going to graph the vertex, 0, negative 1. And then obviously this opens down, and it starts with a decrease of 2 units. And it's going to go 6 units. And then that's enough to form our graph. That's it. Pretty simple. Whoops, a little too wide there. All right, folks, that's it. If you found this helpful or enjoyed the content, like, subscribe, and share. Hopefully this helped you, knowing that there are also left and right facing parabolas. I'll see you next time. Have a great day.